In this video, we will determine Vc0 and Vc infinity for this capacitor when at t equals 0 the circuit suddenly changes. This expression u of t is called the unit step function. When t is less than 0, this equals 0. When t is greater than 0, this equals 1. So at t equals 0, this voltage source suddenly appears. Before t equals 0, this voltage source is not here and simply acts as a short circuit. To determine the voltage across the capacitor at time t equals 0, we need to write this circuit as if it is in the steady state before it has changed. So how does it look before t hits 0? Before t hits 0, this battery does not exist, so there is simply a 10 ohm resistor. There is also the 20 ohm resistor. And what of this capacitor? If we assume that the circuit has been going on for a very long time leading up to t equals 0, then the capacitor is simply a break in the circuit through which no current flows. I will label this as Vc anyway. Finally, before t equals 0, this switch is closed, so there is in fact a 10-volt battery. This means that Vc at time equals 0 can be extremely easily determined because, and think about this for a little bit before I give you the answer. Think. Vc is parallel to 10 volts, which means the voltage across the capacitor at time equals 0 is 10 volts. Now we must determine the voltage across the capacitor at t equals infinity. After this t equals 0, this switch opens up, so this battery is gone, but this voltage source suddenly appears, so we should have a circuit which has a 30-volt battery, a 10 ohm resistor, a 20 ohm resistor, because this is time equals infinity, a broken capacitor, and of course nothing to the right because this switch opened up, so there can be no current and no anything to the right, so the circuit closes up like this. We must determine the voltage across this capacitor, Vc, at time equals infinity, because this is the steady state. Observe that this 30-volt battery can only push current through this loop. This loop does not exist for all intents and purposes. So this is a single loop, and we can use the voltage divider to determine the voltage across this 20 ohm resistor. The voltage divider says that this voltage, Vc at t equals infinity, or the voltage across this resistor, is 30 volts times 20 ohms over the total resistance, 30 ohms. So this is, of course, 20 volts. So Vc at time equals infinity is 20 volts. Now we can fill in the equation. Vc as time passes is equal to the infinity value, 20, minus the infinity value minus the 0 value times e to the negative t over tau. We simply need to determine the time constant. And then we will have some measure of how fast this 10 volt of difference, this 10 volt missing in the capacitor, gradually fades away so that the capacitor fills up with 20 volts. Note that this exact same procedure can be carried out if you had a circuit with an inductor in it. You would simply perform circuit analysis until you determine the current of the inductor in the steady state before t equals 0 and in the steady state after t equals 0. So the steps are simply find the voltage across the capacitor or the current in the inductor in the steady state before t equals 0 and after t equals 0. And to determine the steady state, you can treat a capacitor as a break and an inductor as an open. Inductors as a short.